guys press the change the size of the ship. And we keep it that size. Let's make sure we get those sides good. Okay, that's 16 accuracy. We got $30. That's 20. That counts. Okay, now let's put everything else. Good. Lowering the capacity to make it easier for passing. Oops, I had it too high. Alright, let's Congratulations, you already passed the tutorial. Click refresh to continue. The surface. And this is a mini game where you could throw the trash into the goal. The goal is to click on your finger to play this NASA Internet on the iPad, Mac, on other devices, maybe, I don't know. You can also search for your app store. Let me show you guys something else. Let's start with the first video. The welcome message when you get once you first come.
Coral reefs are a critical part of our life support system. They define us. They define the ocean. They define the planet. But for how important these ecosystems are, we know very little about them. We've mapped more of the surface of the Moon and Mars than we have our own ocean. But we can see enough to know that our coral reefs are in danger. Pollution, overfishing, and rising ocean temperatures are ravaging these amazing ecosystems faster than they're able to recover. In order to fully understand what's happening, we need your help. My name is Sylvia Earle. Welcome to NASA NEMONet. Your mission is to take command of a research vessel and travel the world collecting data on the ocean. As you explore, you will learn about all the different types of coral and how to identify one family from another. Our team of NASA scientists at home base is standing by, ready to use the classifications you create to teach our supercomputer to classify coral reefs on its own. Together, we can create a global data set of classified coral reefs. We can look into the past to see how reefs are changing over time. And we can build a better understanding of how to best move forward to save these aquatic worlds. Good luck and welcome to the NASA team.
Alright, you guys, now I'm going to show you another video. what is the purpose of it? Let me see.
Good work classifying out there. While you were out, we were able to get your research computer on.
Oh, wait, that's not it. Let's start with this one. This one explains it right here. This should be it.
Hello, and welcome to NASA NemoNet. My name is Faith Shariat, and I direct the Laboratory for Advanced Sensing here in NASA Silicon Valley. The goal of my lab is to invent and develop new technologies for the agency to help explore our planet, our solar system, and the universe beyond. In NemoNet, you get the first chance to look at datasets we've acquired using a brand new instrument called FluidCam. FluidCam is capable of looking through ocean waves and mapping corals at the centimeter scale in 3D.
Ooh, anybody know what this part is? Type in the comments below if you know. Anyway. I think this one explains the purpose. I don't know.
Corals are invertebrates classified in the phylum Cnidaria. This is the same phylum that includes sea anemones and jellyfishes, among other very interesting organisms. In the case of hard corals, one of their main features is the calcium carbonate skeleton, which, for many hard coral species, provides the primary structure on which coral reefs are formed. Now, a reef, strictly speaking, is a rigid structure of biological origin, such as a coral reef, or artificial origin, such as a shipwreck, that stands topographically above the surrounding seascape and exerts some control on oceanographic processes. Coral reefs are the largest geological structures built by living organisms on Earth. The Great Barrier Reef in Australia, for example, is easily distinguishable from the International Space Station. Hard corals form the primary framework of these magnificent ecosystems, with thousands of other species of organisms also contributing to its maintenance. In fact, coral reefs are probably the most diverse marine ecosystem on the planet and provide sustenance for millions of people around the globe. Therefore, all coral reefs are reefs, but not all reefs are coral reefs.
Alright, you guys, let's see what else. Now you guys know what coral reefs are. Let's check this video out.
How exactly does our computer algorithm classify corals?
Now this video here, you guys, that I'm showing you, this is the purpose why they made NASA NemoNet, and this person here is going to explain to you guys. And,
how exactly does our computer algorithm classify corals? How does it actually work? It may seem natural to us to identify corals and other organisms, but how will we ever teach a computer to do it?
Dr. Alan Lee, you guys, is going to explain us the purpose of NASA NemoNet and all the other stuff.
This topic is actually a very active area of current research. You might have seen how computers these days can already identify cats, dogs, and other objects. Maybe you've heard of self-driving cars and other new technologies coming up. Well, the algorithms behind NemoNet are very similar. They are based upon something called convolutional neural networks, or CNNs for short. CNNs are like rudimentary versions of the human brain, mimicking how the human brain works with its trillions of neurons firing together to give us intelligence. In a CNN, connections between these neurons are modeled as mathematical equations instead. And when something is learned, some of these neurons are activated while others are not. In this way, we train the CNN to gradually recognize different objects by letting it learn specific features about that certain object. So, when that object is seen again, those same neurons will hopefully fire again, and eventually the object is recognized.
Alright, you guys. Thing I learned. Yes, this. Portrait. Portrait are one of the most common and most diverse families of hard clothes in the world. Portrait tends to form smooth, rounded structure shapes. They also sometimes form branching structures that resemble smooth, stubby fingers. In some cases, portraits form plate structures, thin sheets, curl with a plate structure along thin sheets. It's likely a portrait is smooth and lumpy. Plate. Like portrait, also tends to stack on top of one another. Photo from John Torres presents Charlie Veron and E72 via Adobe Stock. This is a dead cool, you guys. This one is alive. See the difference? Dead. Some of it is dead, some is alive, some is old. See? Tropical portrait. Tropical portrait often has many branches and form tree-like columns. They are usually covered in small circular bumps, columns. Some tropical portrait have several small, thick, and turbo branches with rounded tips. They can be confused with apropods, which also form bumpy, branching structures, but tropical portrait usually have thicker and more rounded branches which connect to a thick base. Tropical can also be confused with portraits. The difference is that tropical portraits are usually covered in circular bumps or have sharper tips. Additionally, there are no tropical in the Atlantic Caribbean. 3D model from the Torres project, photos from John Torres Perez. Portrait, Tropical portrait, portrait. See? Ooh, look at this one, you guys. Looks nice. So this section over here, you guys, when you think about downloading the app to run yourself on your own as well, this is the mail section. You can check the videos that you saw, right? It gives you mail, what you know. It gives you your status. So this is my status. 171 classifications globally. Plus another amazing address. You classified 42 coral. You reviewed 40 submissions. Rate translate 0.8. Played 3 hours, 1.5 hours. Classified 9 sets, 1 night. This is edit and review. This section you could edit yourself, and this section you could review. The curls you already did. These sections are the badges. Use the badges iron. Unlocked by reaching rank 1. Unlocked by reaching rank 2. Unlocked by reaching rank 3. This set unlocked by reaching rank 4. Rank 5. This I unlocked by reaching rank 6. This I unlocked by upgraded by completing 80 classifications, Ocean Specialist. You have completed 42 classifications, that's how I earn Ocean Specialist. This one is travel, but this I unlocked by visiting a new location in the world map. Let me show you guys the world map. I don't know what this shows. Oops. Oh. I'll show you guys next time. That's because I'm still doing the code. This one is a world map. This I unlocked by completing the tutorial. Graduates. This I unlocked today. Veteran researcher. Upgrade by logging in 60 days after my first login. My first login 21 days. That was 21 days ago. That's all the badges I have. So let's classify this. Ooh, did you guys see that fish? So this here, you guys, is called. This here, you guys, is the 2D map. This is the 3D map. Here, it gives you classified coral. So on 2D map, on the world map, it'll give you an option of what place you want to go to classify the coral. And once you select that place, it'll ask you would you want it in 2D or 3D. In 2D, it does this, for example, even though there's no green analogy here. You could do this, right? Let me show you better example. This is the erase button. If you don't want to click that undo button, just click erase. This is the erase button. Alright, so let me show you. So I do this, right? I color this by green, even though it's really there's no green out. See? Ta-da! Magic. Yeah, that's the right button I have on, but just to make sure I know the words in the one I have on. Plus, you could also decide if you want how you want it to operate. If you want it to where it works for you left-handed or right-handed. So, see, mine's just right-handed because I'm right. No email attached to this account. You could add it to. You can add a username and you can visit the website. Alright, Space of Friends. That is the end of this science video for today. Bye, you guys.